Alright guys, we're going to keep working on the lesson from yesterday. I think this is the problem we were going to, or the next one that we had. Yes. Pull the calculator up. So, again, the flow chart is going to be very helpful, especially for the assignment, because it's going to help you determine which one it is. Because the nice thing with the flow chart it determines and lets you know how many solutions we should have, 1, 2, or no solutions. And some of the ones that are no solutions are going to be very nice because, well, once we know it's no solution, we're done. We don't have to do any other calculations after that. So if we look at this here, we have two sides and an angle. So we would go that route. The next question is the angle greater than or equal to 90 degrees? The angle is 31 degrees, so no, it's not. The next question after that is A less than B, or A is greater than or equal to B? So is the side opposite greater than the other side given, or less than it? Well, A is greater, so we'll have one solution. And to really start this off, we need to find one of the two angles. And the angle that we find first is always going to be the one opposite the other side length we were given. So here, we're going to need to find angle B first. So to do that, we're going to use sine of B over side length B is equal to sine of A over side length A. Well, the first thing we're going to do is multiply both sides by 5, telling us that sine of B is equal to 5 times sine of 31 over 12. But to get rid of sine, to get just angle B, we've got to apply sine inverse to both sides, which is really telling us that angle B is equal to sine inverse of 5 sine of 31 degrees all over 12. And at this point, we can plug the whole thing into the calculator. So second sine inverse alpha y equals enter 5 sine of 31 over 12. So we'll go to the nearest tenth, still 12.4 degrees. Questions on how we got any of this here? So angle B is 12.4 degrees. Measure of angle B, 12.4 degrees. So now all we have left is finding the length of C and the measure of angle C. Well, finding the measure of angle C is not too bad because we can add the two angles that we do have together and subtract it from 180. So 180 minus 31 minus 12.4 exactly is 136.6 degrees. Well, knowing that angle C is 136.6 degrees, we should expect C to be way bigger than 5 and 12. Just because of the angle properties, the biggest side is opposite the biggest angle. And lastly, to find C, we're using the other one. And really to tell the difference between the two, if you're finding angles or looking for angles, sine is going to be on top of the fractions. If we're looking for sides, little a, little b, or little c, those are going to be on top. Side lengths on top if we're looking for sides, angles on top if we're looking for angles. So here we're going to have C over sine of 136.6 degrees is equal to, well, I would pick 12 over sine of 31. I picked these here because they are the exact values. We didn't have to approximate or round to get them. And lastly, we're going to multiply both sides by sine of 136.6. These here will cancel, telling us C is equal to 12 sine of 136.6 degrees over sine of 31. And if we round to the nearest tenth, it's just going to be 16.0. And that's it. Questions on this here? Not too bad. All right. Let's look at the next one. So this time they didn't give us a triangle to start with. Some of the ones on the assignment won't. They'll just give you the side lengths. So one of the things we could do is I can just draw a triangle A, B, C. It doesn't really matter how you set up A, B, C. You just need to pick them. They tell us that angle A is 85 degrees. They tell us side length A is 15 inches, side length B is 25 inches, and we want to find the rest. So we have side length C down here. Okay, so what information is given? We have two sides and an angle. Is the angle greater than or equal to 90 degrees? Well, no. The next question is A less than B or greater than or equal to B? So side opposite the angle, is it bigger or smaller than the other side? This time it's smaller, yes? So that opens up to a different branch we haven't covered yet. We have three equations, and they're dealing with A and B sine of A. So the side opposite the angle given and B times sine of the angle. Now there's one of three options. It's either going to be A is greater, A is equal to, or A is less than. Because if A is greater than B sine of A, we have two solutions. If A is equal to B sine of A, we have one. And if A is less than it, we have none. So here, we can kind of plug the information in. We know that A is 15. B is 25 times sine of 85 degrees. Now at this point here, I can just grab the calculator and do 15 sine of 85. And we get 14.94 going on, yes? Ah, yes. $24.90. That's a better number. 24.90. And how does it relate to our 15? Well, it is. So 15 is less than it, yes? A is less than B sine of A. So which one does it tell us that it is? So this here is questions on this here. Now, you're probably wondering why there was a weird box located on the page. So this here, let me draw. Here is the actual length set up in scale. So if we scaled these out, These would how the lengths would actually look. And we can see, because this here is 85 degrees, marker back, which means this is our 15 inches and this is our 25 inches. There's no way we're actually going to be able to make a triangle. This is why it doesn't work. Does that make sense? So, let's look at the next one here. So luckily and nicely, they do continue to use A and B in angle A. So we have two sides and an angle. Well, the angle is still less than 90, so no. Here, A is less than B. So we're back to A and B sine of A. Well, A is 4. B is 14 sine of 16. 30, 45, 60. So I think this would be 7 square root of 3. Or if we got the approximate decimal answer, it's going to be somewhere in the 14s or close back to 14. I would approximate. Probably not. Sine of, yeah. So 12. But either way, we can definitely say that the B sine of A is bigger, so this is no solution. Now there is one other spot where we can have a no solution. That is if the angle is greater than 90 and side length A is less than B or equal to B, it won't work. Because if that's the case, greater than 90, we have a right angle where this is B and this here would be A. If they're equal, the point that they would hit is going to be right there at the angle itself, so we wouldn't actually have a triangle. And if it's less than it, it'll look exactly like that there. It's not going to come back. Any questions on this here? All right, let's look at the next one here. So again, most of the ones we're going to do from here on out, A is going to be, it's going to be two sides and an angle. Here, the angle is not greater than 90. And A is less than B. So we're going back to our 3. Here are A and B sine of A. A is 12. We have 31 sine of 20.5. So again, we can do 31 sine of 20.5. And this time we get 10.856, so on. So 12 is greater than it, yes? Which means we have how many solutions? 2. So most of these calculations, especially with this here, I would do it, I wouldn't do it big, I would do it small off to the side just so we know how many we have. Because this time we have 2. Now the first thing we're going to do to start this off, because we'll need to find for sure angle B, angle C, and side length C. Now if you want to name them as angle B sub 1, angle C sub 1, and angle or side length C sub 1, that's fine, because we're also going to have a second value for B, a second value of C, and a second side length for C. We're going to have 2 of each.
Allie Jones, come to the office. Allie Jones, come to the office.
Because if you remember yesterday when I was going through and showing you on the overhead projector, where we had the one where it hit the triangle or hit the other side twice, that's what we have. We're going to have 2 different triangles, so there's going to be 2 different values for each one of these here. Now the way we start off is not any different than we did with one solution. I'm going to have to find angle B first. So we'll have sine of B over 31 is equal to sine of 20.5 over 12. Same setup. Now we're going to multiply both sides by 31. These will cancel, telling us sine of b is equal to 31 sine of 20.5 over 12. And again, we're going to take sine inverse of both sides, telling us b is equal to sine inverse of 31 sine of 20.5 all over 12. So at this point here, nothing's changed. Would we agree with that? 31, 20.5, 12. 1 sine of over 12. I believe I typed that incorrectly. Enter. We get 64.7832 going on. We'll round to the nearest tenth, so 64.8. And we can call this B1. Questions on this here? We good with this here so far? Now, I've always tried to relate this back to the two triangles and trying to understand how we get B2, but I finally got it to make sense for myself. If we think, and it's in proportions to the unit circle, sine is positive in the first and second quadrant, yes? So dealing with reference angles, if I subtract this from 180, we get what value would be in quadrant 2, where they would have the same. So here, if we're trying to find the second angle, we're just going to take the 64.8 and subtract it from 180. So we can say 180 minus 64.8. 7, 10, 2, 5, 1. So the other angle B is going to be 115.2 degrees. So those would be our two triangles, the values of B. Questions on this so far? Define C. 1, we add 20.5 degrees and 84.8 degrees and subtract it from 180. So 20.5 plus 64.8. That there, 180 minus 85.3, which tells us C1 is 94.7 degrees. $115.2. Then for the other one, 115. Okay. Try this again. 15.2 plus 20.5. We can add those A and our other angle B together and subtract it from 180. I know it says negative 44.3 degrees because I did it backwards, because we should have subtracted it from 180, not 180 from it. But knowing that I have it the wrong sign, it's just telling me it's 44.3. Questions on any of this so far? Not been too bad, because really all we did was find angle B, subtract 180 to get the other angle. Added those two angles together, subtracted it from 180 to find the third angle, yes? Now the only other thing we need to do, I'm going to erase this so I'm not having to scroll down, is find side length C. Now the way I set this up intentionally. I don't use side length B or angle B, because angle B in both cases change, yes? What's the only angle that stays the same for both triangles? A, because A is 20.5 for both, yes? So for the other one over here, I'm going to use 12 over sine of 20.5. C over sine, doesn't matter which one we do first, so we can say 94.7 degrees and solve this here. So I would multiply both sides by sine of 94.7 degrees. These here would cancel, telling me C is equal to 12 sine of 94.7 over sine of 20.5. We get 34.15 or 34.2. Any questions on how we found C1 or the first side C? We good with that there? What's the only difference between this one and the other C? The angle is what? 44.3 instead of 94.7, yes? Would any of the math or calculations I did here really differ besides the fact that this angle right here is going to change? Well, no, right? So really all I'm doing is taking this angle and replacing it with what? 44.3, yes? So the other C value is really going to be 12 sine of 44.3 over sine of 'I could go back through and rewrite out C over sine of 44.3 is equal to 12 over sine of 20.5. Multiply both sides by sine of 44.3 and get here. And the nice thing with the calculator is I can recall that value and come over here and say 44.3. 23.9. That's it. Questions on this here? Questions on anything we've done so far? We feel pretty comfortable with this here? Because this here, even though it's two solutions, it's nothing more than what we've been doing. The only kind of real trick is once we find angle B, subtract it from 180 to get the other. Add them together to find the third, and then just do the same thing with finding the last length. Any questions on any of this here? We need to see another example of two solutions. We feel pretty comfortable with these here. If that's the case, this here is the last thing we're looking at with these. And the text I noticed is kind of small, especially on y'all's page. But the area of a triangle, the formula that we're normally used to, is 1/2 the base times the height. And this works if we know the base and the height. And in a right triangle, the two sides that make up the right angle are the base and height. We multiply those together with 1/2 and we get there. However, if we don't have that, we have this other formula here. So if we have the two sides and an angle in the middle, two sides and an angle in the middle, we can use this formula here. Area is equal to 1/2. So our two sides, so here it's telling us two sides are 90 and 52, and an included angle of 102 degrees. So all that's telling us is 90 times 52 times sine of 102. Now, if we're not given the two angles and the side between, we got to find one of the other sides. So using law of sines to find the other missing side, to go from there. But if we have the two sides and an angle in the middle, we plug it in the calculator, and we're done. 95, 52, 102. Here's 95, 52, sine of 102 degrees. And we can go 2 decimal places out for this here, or 1, just depending on what the instructions say. And I don't think it specifies for this here. 2416.02. And we could use the units meters squared. But that's it. I use 0.5 instead of 1/2. They're the same thing. 0.5 is a little bit easier to type in on the graphing calculator. Questions on this here? Kind of like this one. So this here is helpful because now we're able to find the area of any triangle without having to find the height. Or at least if we have the two sides and an included angle. Well, these are the exact same problem. Any questions on any of this here? Are you ready for the massive homework assignment? Five, 7, 19, 24 through 27, 32, 37 through 40. 1, 2, 3, 4, 5, 7, 19, 24, 25, 26, 27, 32, 37, 38, 39. I think that's 12 problems. So that's it. That's all we're doing for this here.